Today we're going to talk about scales, so let's get started. Dealing with scales isn't too bad, but the tricky part is the wording. So we're going to look at an example. 1/8 of an inch on the drawing represents 1 foot. How long on the drawing would you have to show a pipe that is actually 3 feet 11 inches? The trick really is to set up two separate fractions. So in my case, I'm going to show drawings on the top and actuals on the bottom. That being said, it's totally okay if you switch these two around. Put the actual on the top and drawing on the bottom. But I'm going to put, as I said, drawing on the top, actual on the bottom. So my drawing has 1/8 of an inch on the top, means that it is 1 foot. It's going to equal another fraction. What I'm trying to find out is how long on the drawing. So I don't know that. I'm just going to call it x. And it's actually 3 feet 11 inches. Now we have a little problem. We know that the actual has to be in terms of feet. So we have to change the 11 inches. Not a problem. It's 3 feet, so we're just going to keep that. And then we're going to change the 11 inches into feet as well. And so we're going to divide it by 12. So 11 divided by 12 ends up being 0.91667. Do not make the mistake of rounding too early. Right? We want to work to 4 or 5 decimal places. The more decimal places you have, the better. I usually work to 5. So now I have 3.91667 feet. And now I can adjust my fraction. So I rewrite my fraction. Instead of the 3 feet 11 inches, I figured it all out, and it's 3.91667. And I do some cross multiplication. So the 1/8 times 3.91667 and the 1 times the x. When we do those multiplications, it gives us 0.48958, which is equal to x. Now remember, your x is in inches. So the pipe on the drawing would be 0.48958 inches. Now let's do another example. The scale on a drawing shows that 1 foot is the same thing as 3/4 of an inch. The drawing shows a duct of 2.36 inches. How long is the ductwork that you need to order? The tricky part of this question is realizing that, you have a choice of 1 foot or you have the choice of 3/4 of an inch. It doesn't make sense to have the drawing be bigger than the actual. So what we're going to do is, same as before, we're going to set up actual over drawing. And we're going to set up our fraction again. So feet are in the top. The actual amount is 1 foot. And the drawing amount is 3/4 of an inch. And that has to equal the next fraction. The drawing shows 2.36. What you have to figure out is how much you actually have to order. Now this time this is already in inches. Everything's in inches, so we don't have to change anything. We're all good. You just have to cross multiply. Problem is that it's not 1 times x, it's 3/4, so 3/4 has to go to the other side. So 3/4 is a multiplication on this side, so it has become division on the other side. And 1 times 2.36 is simply 2.36 divided by 0.75, or divided by 3/4, which is the same thing as 0.75. So 2.36 divided by 3/4 is 3.14667. And remember that your x is in feet. It's in the top. It's feet in the top, so it's 3.14667 feet. Now it's possible that they want the answer in feet and inches, so it's not a problem. We're going to change this into feet and inches. So it's already 3 feet, so we're not going to change that. It just ends up being still 3 feet. And we're going to have to change this into inches. So it's 0.14667 of a foot. So we're going to change that times 12, because there's 12 inches in a foot. So it ends up being 3 feet, 1.76004 inches. And we're probably just going to round that up and just say it's 3 feet, 2 inches that we have to order. The final example we're going to do is the metric system, which is really pretty neat. A scale is 1 to 1,000. This means that 1 millimeter on the drawing is actually 1,000 millimeters, or 1 meter, in real life. The drawing has a trench that is 3.75 centimeters long. How long is the actual trench? So we're going to set this up exactly the same way that we always do. Just set it up with drawing and actual, and we're going to create our 2 separate fractions. So the drawing has 1 millimeter, which is the same thing as 1,000 millimeters, is equal to, the drawing shows 3.75 centimeters. I'm going to come back to that in a second. And we're trying to find out how long it actually is. So we're just going to call that x. And we have to remember that this top part all has to be in terms of millimeters. So we're going to change that 3.75 centimeters into millimeters. And remember that every centimeter has 10 millimeters. So we're going to multiply it by 10. And so now we've set up our new fraction. And now we're going to cross multiply and figure out our value for x. Our x ends up being 37,500. Now remember, the x is in millimeters. So it's possible that they're going to want to change this to be in meters. So you're going to divide the 37,500 by 1,000, because there's 1,000 millimeters in a meter. And that's going to give us 37.5 meters. So the big thing about scales is just making sure that you set up drawing over actual and have 2 separate fractions. It's not too bad, which is what I said at the beginning. Talk to you soon.